Hello learners, welcome to another session on statistics in psychology. In this session we are going to further discuss about the measures of variability. This is the second part of measures of variability. In the very first part of the measures of variability, we discuss what variability is all about, and we discuss about the significance of the variability, role of the variability. As you know that in the descriptive statistics we generally discuss about the three things. One is called measures of central tendency, second one is called measures of variability, and the third one is called measures of correlation. In the context of measures of variability, we have already discussed more about the measures of variability, what it is all about. In this session, basically we are going to talk more about the different types of variability. In the measures of variability, in the previous session we discussed about only initial measures of variability, which is called range. In this session, we are going to talk about further measures of variability, which is also equally important and more significance for the further analysis of the data. And these measures of variability is known as, first is quartile deviation, the second one is average deviation, which is also known as the mean deviation. Then we will also discuss about the standard deviation and variance. Let's start with the first concept, which is called quartile deviation. Since the large number of the values in the data lies in the middle of the frequency distribution and the range depend upon the extreme scores outlier of the distribution, we need another kind of variability. So the range that we have discussed so far is not that much effective, where in the range only we consider two scores. One is and both are the extreme scores. One is the minimum score and the maximum score. In order to understand more about the data variability of the data, let us discuss about another kind of measures of variability, which is called quartile deviation. So the quartile deviation is measure that depends on the relatively stable central position of the distribution. Central position in the sense we will discuss more about it. You can understand what actually central position is all about. So according to Garrett, the quartile deviation is the half the scale distance between 75th and 25th percentile in the frequency distribution. So whatever the position which is there in the 75 and 25th position in quartile deviation is nothing but it's a half the scale distance between the 75th and 25th percent in a frequency distribution. So entire data is divided into the four equal parts, and which is called quartile. Quartile means 25%, and each part contains 25% of the value. And by looking all these things, by using this data, we basically trying to identify the quartile deviation. So to understand the quartile deviation, let me discuss another important point here, which is called interquartile range. The range which is computed for the middle of the 50% of the distribution is called interquartile range. The upper quartile range is the Q3. If you distribute the whole data in ascending or descending order, you can understand that the first 25% data is called Q1, then the middle is the Q2, then the 75 is Q3, and the end one is the Q4. So the upper quartile, which is called Q3, means the 75% and above. Lower quartile is called 25% and below, is used to compare in the interquartile range. So in interquartile range we calculate with the help of Q3 minus Q1, which is called quartile range of the Q3 minus Q1. So it is Q3 stand for the 75% of percentile, and Q1 is the 25 percentile. So IQR, which is also acronym which we use for the interquartile range, is not affected by the extreme score. So as you have seen in the range that if you are not aware about the range, just I would suggest you to go and see the previous video in which we have discussed about the range. Here I am using the concept of range to understand how the quartile deviation is somehow more understandable of the data as compared to the range. So in interquartile range, what we do, we do not consider the extreme value, and in the range we actually consider the extreme value. So to eliminate the extreme value, what we do in the interquartile range, we consider Q3 and Q1, which stand for the 75 percentile, and Q1 stand for the 25. So semi-interquartile range is also known as the quartile deviation. So what is interquartile range? Interquartile range is the Q3 means the 75% percentile, and Q1 is the 25 percentile score, and we subtract in between them, means Q3 minus Q1. When we divide Q3 minus Q1, we get quartile deviation. So it is nothing but which is can be also consider semi quartile range. When we divide by 2, or we can say when we do half of the IQR, which is called interquartile range, we get quartile deviation. So half of the IQR is called semi-interquartile range, and semi-interquartile range is also known as quartile deviation. So you can understand how do we calculate the quartile deviation. Quartile deviation QD is equal to Q3 minus Q1 divided by 2. So Q3 minus Q1, whatever the score we will get, we divide by 2, and which is also known as the semi-interquartile range. So Q3 minus Q1 is nothing but it's interquartile range. When we divide by 2, which is called semi-interquartile range, and we get quartile deviation. So thus the quartile deviation is obtained by dividing IQR by 2. So quartile deviation is an absolute measure of dispersion and expressed in the sum of the unit as the scores. So before going to the discussion more about the quartile deviation, what are the significance and importance of this quartile deviation and limitations, let us go with the calculation part. So how do we calculate the quartile deviation? So suppose I can see there are a set of data which is reflecting in your screen, and in this data, through this data we can try to compute the quartile deviation, and this data is ungrouped data, in which you can see that there are total 11 number of data set, in which it is start with the 24, 25, 23, 26, 29, 30, 27, 35, 34, 36 and 28. So in the very first step, what we do, we arrange them into the ascending order. So ascending order, it means that the minimum would be first and the maximum would be the end one. So you can see in the very first step what we do, we arrange the data set into ascending order. Step 2, we compute Q1, because in the quartile deviation we have a formula Q3 minus Q1 divided by 2. So we have to compute Q1, and how do we compute the Q1? There is a formula through which you can compute the Q1. As similar, you can recall what you do to calculate the median of the ungrouped data. Similarly, we have to calculate the Q1, which is called 25th position of the data in the ungrouped data set. So Q1 is nothing but is equal to n plus 1, where the n is the number of the total number of the data plus 1 divided by 4 position. So here we have total number 11 plus 1 divided by 4 is equal to, of course, 12 by 4 is equal to 3. The third position in the ascending order, you can see that there is a 25 score. So 25 is the number which can be considered as the Q1. Similarly, we calculate for the Q3. Here we have to calculate the 75th position. So as you know that in the Q1 is the 25th position. So Q3, the formula would be only 3 multiplied by n plus 1 divided 4, means the 3 into 25th position. So again n number is 11, and Q3 would be 3 in bracket 11 plus 1 bracket divided by 4. So it would be 9. So 9th position you can see in the data set in the ascending order, and you will get the score 34. So here we have got the two score, one is Q1 which is 25 and Q3 is 34. In the step 4, what we do, we calculate simply quartile deviation. So what we do, we generally calculate Q3 minus Q1, which is 34 minus 25 divided by 2, which is called 9 divided by 2, and which we get 4.5. So in this example, you can understand how do we calculate quartile deviation for the ungrouped data. Similarly, for group data, we have a different formula, although we have to calculate the same thing, which is called Q3 minus Q1 divided by 2. If you can recall the calculation of median in the group data, similarly we have to calculate for the Q1, which is 25th position, and Q3 is the 75th position. The formula is given in your screen. Here you can see that the Q1 is equal to 1 plus I bracket close n by 4 minus CUMFI, which is known as cumulative frequency, and divided by FQ, which is called actual frequency. CUMFI, which is known as the cumulative frequency of interval which is contained the quartile. So whatever the quartile interval you have selected, the cumulative frequency up to that quartile interval, which can be considered as the cumulative frequency, and the actual frequency of that class interval would be considered as the FQ. So let's come to the example through which you can understand how do we calculate the quartile deviation from the group data. Here the steps are remain same as we have seen in the first ungrouped data for the ungrouped data. So step 1 is to calculate the Q1 and Q3. So similarly you can see in the screen Q1, how do we calculate the Q1? Here we have to decide whether which class interval would be the Q1 class interval, and for that what we have to do, we have to divide n divided by 4. So n here is of course n by 4. When we go and see the n by 4, we will get a score which is called 12.5. And where is the 12.5? And 12.5 is the score where we can get the quartile range, or we can say in other words the first quartile group. So how do we decide first quartile group? Of course we take n by 4. So total number of frequency divided by 4. So n by 4 you will get 12.5 here. So 12.5 would be considered as a first quartile range. So just go and see the cumulative frequency. You can see the quartile 12.5 comes under the class interval 162, 164. Before that we have 10 cumulative frequencies. So the 12.5 would come under the 14 cumulative frequency class interval, and this class interval is 162, 164. So let's come to the formula. First, I is equal to, of course, I is equal to the class interval, whereas L is equal to exact lower limit. 160 to 164 class interval, we have an exact lower limit is minus 0.5, which is known as 155.9. Similarly, we have cumulative frequency below the class interval, which is 10. As you can see in this class interval, we have 14 cumulative frequency, and below it the 10 cumulative frequency. So the CUMF would be 10, and of course the frequency would be 4, because this class interval contains 4 frequency, and I is equal to 5, which is called class interval. By using all these things, you can get the Q1, and you can see the calculation. The Q1 is equal to 159.5 plus 5 bracket close 12.5, which is n by 4, minus cumulative frequency, which is 10, divided by bracket close divided by 4, which is the frequency, and is equal to 162.62. So this is how you can calculate the Q1, and similarly you can calculate the Q3. In the Q3 you have to select the quartile range according to the 3n by 4. So by doing 3n by 4 you will get 37.5, and this 37.5 definitely coming under the into class interval which is 175 to 179. So accordingly you can calculate all the value to compute the Q3, and you can get the Q3 score, which is somehow 179.19. So in the final step we use the quartile deviation formula, Q3 minus Q1 divided by 2. So Q3 is nothing but it's 179.19 minus 162.62 divided by 2. So Q3 is 179.19, and we have calculated Q1 is equal to 162.62. So and we divide by 2, so we will get a score 8.28. So with this we can calculate the quartile deviation for group data. So in the group data, let me briefly once again summarize what we do. We do first identify the class interval which contain Q1, class interval which is contain Q3. And how do we do it? We divide n by 4, we get Q1, and by dividing 3n by 4 we get Q3, and accordingly we decide the class interval, and we identify the scores which is required for the calculation of Q1 and Q3, and we finally put the value of Q3 minus Q1 divided by 2, and we get the score in quartile deviation. and here we get a score 8.28. So as far as the merit of the quartile deviation is concerned, we can say the quartile deviation is better measured as compared to the range, of course, because it counts 50% of the data which comes under the Q1 to Q3, and we can say which comes under the 50% of the center of the data. Unlike the range is basically based on the two value only, that is the highest value and lowest value. Secondly, the quartile deviation is not affected by the extreme score, because we are not considering any extreme score in the quartile deviation calculation. It is not considered 25% of the data from the beginning and 25% data from the end. So all these extreme score has been eliminated in the calculation, because we consider that the extreme score somehow not gives us proper picture of the dispersion. So what we do in the quartile division, we eliminate all these scores which is extreme of the highest of the 25% and lowest of the 25%. We consider only the center of the 50% score, which is called Q1 to Q3, and we compute the quartile division. So lastly, the quartile division is only measure of the dispersion which can be computed from the frequency distribution with the open-ended classes. So when we have open-ended classes, definitely we can use quartile division, because in the open-ended classes we would have a kind of extreme so open-ended class interval, and we are not considering here the maximum or minimum score. Therefore we can easily go with the quartile deviation, because in the calculation of quartile deviation we don't use any extreme scores. So therefore, for the open-ended class interval, the quartile deviation is the only measures through which we can compute the measures of variability. As far as the limitation is concerned of the quartile division, it depicted the major merits of the quartile division. Definitely there are certain limitations as well. This value of quartile division is based upon the middle of the 50. Again, we are somehow eliminating rest of the 50 of the data. It is not based on the all observation. Thus, it is not regarded as a stable measure of variability, although it is better from the range, but not completely fine, because again we are only considering the center of the 50% of the data, and we are eliminating maximum or minimum 25% of the data. So the value of quartile division is affected by the sampling fluctuation. If the sampling fluctuation is there, definitely it would differ. So the value of quartile division is not affected by the distribution of the individual values within the interval of the middle 50% of the observation. So middle 50% of the observed value is the value of the quartile division, is not affected by the distribution of the individual value within the interval of the middle of the 50% of the observed value. So this is a kind of limitations we can say about the quartile division. As far as the use of quartile division is concerned, the distribution contains few and very extreme scores, means distribution contains very few and very. So when the median is the measure of central tendency, we can easily go for the quartile division. When our primary interest is to determine the concentration around the median, around the 50% of the center of the data, we can go for the quartile division. So this is the kind of use we can say for the quartile division. Another kind of deviation, what we say variability or measures of dispersions we have, which is called average deviations. So let us discuss about the another kind of measures of variability, which is called average deviation. In somehow average also indicate with the mean, so mean deviation or average deviation. So in this average or mean deviation, we consider all entire data in the calculation of the variability. So the two measures of variation, range and quartile deviation, which we discussed definitely in the earlier subsequent discussions, so do not show how the value of the data are scattered about the center of the value. R and QD means the range and quartile deviation attempt to the compute spread of the value, not compute how far the value are from their average. Means it means both of them, means the range and quartile deviation hardly actually do not explain that how the data is spread and the value, and not compute how far the value are from their average. The measure of variation As a degree to which the value within the data deviated from their mean, we use average deviation. So within the data set, how one individual data is differ from or deviate from the mean score, their mean score, we use average deviation. So according to Guilford, in 1963, average deviation can be described as an average or a mean of all deviation when the algebraic sign are not taken into account is considered as the average deviation. So deviation of each data from the mean without considering the sign, whether it is positive or negative, when we calculate the average, we compute average deviation. As far as the merit and limitation of the average deviation is concerned, of course, the main merit of the average deviation is very easily to compute or understand as well. It is based upon the all observation, unlikely to the RMQD, where we have only stream score or only 50% of the score. But in average deviation, we consider all the scores. We will see how do we do it in the calculation process. So let me go first in the calculation, and through which you can understand how do we calculate, and then we will further discuss about their limitations and significance. Merits and limitations we will discuss further when we calculate the average deviation. So what is the formula of average deviation for ungrouped data? Of course, and for group data we have two different formula, but the formula will remain same. The deviation that we have to calculate of each score from the mean of their data set. So AD is equal to summation of modulus of x and divided by n. Here a small x we use in order to represent the deviation of the score from their mean. Modulus means after all we calculate only the positive scores of the deviation. We do not consider the negative, because the reason is the simple that when we calculate the average, when we consider the negative value, it would comes under the zero scores. So therefore we cannot get a proper score of deviation. So we eliminate the sign, and in order to eliminate the sign we use the modulus. So summation modulus x divided by n. So here a small x is nothing but it's a deviation from the mean. How do we calculate deviation from the mean? Let me discuss step by step. So the very first step is to calculate the mean of the data set. So as you can see, there is a table of the data which has a 5 data set, and in this 5 data set the total score is 50. And how do we calculate the mean? 50 divided by 5 is equal to 10. So the very first step what we do, we calculate the mean, and now this mean score has to use to see whether each score is deviating from mean at what extent. So what we do in the second step, we compute, we subtract this mean score from the actual scores. So in the data set that is reflecting in your screen, you can see that the very first score is 6. So how do we calculate the deviation? We calculate the raw score, which is 6 minus mean, is equal to 10. So 6 minus 10 is equal to minus 4. And as I told you earlier that we do not consider the sign of the value. So ultimately when we calculate the overall deviation, we eliminate the sign of the score. So here we get minus 4. Similarly for the score like 14, we get 4 score. 14 minus 10 is equal to 4. So similarly we calculate all the deviation of the individual score from the mean, and we then the fourth step we compute overall average deviation. And how do we do it? We compute these deviations with the help of formula, and the formula is nothing but we have a formula is equal to modulus of x divided by n, and the modulus of x, summation of x we get, which is 12. And which we do not consider any sign, then we can calculate it is 12. So 12 divided by how many data is there? 5. So 12 divided by 5 is equal to 2.4. So this is the calculation of average deviation. And for the group data, we definitely use formula like the AD is equal to summation of fx, where the frequency comes in this picture, and x is the capital scores, and divided by n. So again for the computation of average deviation for group data, we use the same formula, but here the frequency comes into the picture, and we use the class interval. Here in the class interval, how do we calculate the mean score? If you can recall, you can easily calculate the average deviation, which has a similar formula. So what we do in the group data, first we calculate the middle score and we multiply by the frequency, we get fx, and we compute the mean of the data set. And again we have to do the same thing, we subtract the mean score from each of the middle score of the class interval, and we get another score, and we multiply by f, which is called frequency, and we get fx. Here the x is the small x, which is deviation from the mean. So the score that we have to use in the middle in the class interval or group data, which is the middle score. By using all these steps that we can see in the screen, and we can calculate the we can easily calculate the average deviation. So in average deviation, we nothing but the similar as the for the ungroup data. In the group data, we only use the frequency and capital scores, capital middle score, and which is known as capital X. And later on, we see the deviation from the mean. We multiply by x, and we sum all the fx, and we do not use the sign. Therefore, we say it's a modulus of fx and divided by n, and we get the score. So for this example, you can see the score is nothing but it's a 7.73, and which is also average deviation of these scores. So you can easily calculate by using your own understanding, which you have already know about it in your previous discussions, like how do we calculate mean score for the group data. Let's talk about their merits and limitations. As far as the merits and limitations is concerned of average deviation, so it is less effective by the extreme score, no doubt about it, and it is based upon the average. Thus, it is better measure of the compare about the formation of the different distribution. The main limitation of the average deviations as follows. Why? The main limitation of average deviation is while calculating the average deviation, we ignore the plus minus sign and consider value only the plus. Because of this mathematical property, it is not used in the inferential statistics. So we do not use this average deviation in inferential statistics because we are eliminating somehow the sign of the within our calculation. So AD, which called average deviation, cannot be computed for the open-ended classes, because if you have not all the classes, we cannot use the average deviation, because for average deviation we require all the data set. It tends to be increased with the size of the sample. The average deviation generally increase with the size of the sample. So this is the limitation. Let's talk about the another kind which is very useful and frequently we use it for the inferential statistics, which is called a standard deviation. So the term standard deviation was first used by Carl Pearson in 1894, and the standard deviation of the population is denoted by sigma. The Greek letter sigma is the representation of the standard deviation for the population, and for the sample we use small s. So the standard deviation indicates the average of the distance of all scores around the mean, and it is a positive square root of the mean of a square deviation of all score from the mean. So it is a positive square root of variance. So variance is nothing but the square of the standard deviation is called variance. So we will discuss more about it in a further discussion. Here you can understand standard deviation. Somehow we also explain the variance. Square root of the variance is called standard deviation. In the vice versa, we can say variance is the square of the standard deviation. So it is also called as the root mean square deviation. So a standard deviation shows that how much the variation there is from the mean, and a standard deviation is calculated from the mean only. So how do we calculate? The formula is like this. The standard deviation is equal to square root of summation of x square. Here the x small is the deviation, which we have already discussed. How do we calculate the deviation? Square divided by n. So here small x square is the deviation of each score from the mean, and the summation is the sum of all deviation from the mean. Here square actually eliminate the sign of negative. So when we square of negative value, then it becomes the positive value. So here there is no need for the modulus. So here the square basically eliminate the sign. So standard deviation formula is square root of within the square root we have sum of small x square divided by n. And when we calculate standard deviation for the group data, we only put the value which is called f, which is called frequency. So for the group data, standard deviation formula would be within the square root we have summation of fx square divided by n. So by using the previous understanding, you can easily calculate the deviation from the mean. Here what we have to do, we have to add one important thing, which we have to square the deviation. So we know how to calculate the small x. Small x is nothing but which is deviation from the mean, and once we calculate the small x, we square the small x and then we sum all the square of deviations and we get x square, summation of x square. When we have a group data, we multiply by f to individual x square and we get fx square, summation of fx square, and when we divide by n, then we get the variance, and when we square root of this, when we do a square root of the variance, we get a standard deviation. So a standard deviation, in this example you can see the very first step is to calculate the mean score, the second step is to calculate the deviation from the mean score, and then we square the deviation, then sum of all the deviation and put all the value into the formula and get the result, which is SD is equal to sum of the x square, which is 382 divided by 8, and which is under root 47.7, and we get the score 6.91, which is the SD score for this example. Similarly, for the group data, we can easily calculate by using previous understanding. Only the formula will remain same. Here the formula which we have seen in the average deviation, which was fx divided by n, where we had no such kind of a square root. Here we have a square root, summation of fx square divided by n, and here we have to use frequency multiplied by x square. In the ungrouped data, we do not have frequency, but in the group data, we generally have a frequency. So what we do, we multiply deviation x square by individual frequency and we get summation of fx square. Here x is the small x, and which indicates deviation from mean for each individual score, and when we square it, we get x square. So the formula will remain same for the standard deviation of the group data, and steps are remain same. First we have to calculate the mean of the data set, then we have to calculate fx, then we have to calculate fx square. Of course, x is nothing but the x square is nothing but the deviation from the mean. When we calculate the small x square, then we multiply by f and we get summation of fx square. When we divide by n, we get variance, and when we square root of these scores, square root of fx square, sum of fx square divided by n, we will get a standard deviation. So in this example, you can see in the screen, the standard deviation is 7.97. So the standard deviation has also certain merits, certain limitations. So it has a good merit because it used extensively in the inferential statistics. The main merit used standard deviation is it widely used because it has a best measure of variance, or we can say the best measure of dispersion in a mathematical characteristics. It is best for the observation of the data. It gives accurate estimate of the population parameter when it compares to the other measure of variation. So a standard deviation is the least affected by the sample fluctuation. If the sample is fluctuating, you are drawing more sample, then it's less affected. It is also possible to calculate combined SD. That is not possible with the other measures. Of course, the further statistics can be applied on the basis of standard deviation, like correlation, regression, other tests like t-test and other tests. You will be encountered with all this analysis in a further discussion, and you will see how you are going to use standard deviation in the further analysis. And it is, as far as the limitation is concerned, it is difficult to compute and compare to the measures of dispersion. The reason is the calculation is little bit tough as compared to the other measures of variability or variances. Next we have another kind of variance which is also common, and we have already discussed about it. So variance is nothing but variance was used to describe the square of the standard deviation, and it was used by R.A. Fisher in 1913. The concept of variance is of great importance to advanced work where it is possible to split the total into the several parts into the attribution to one of the factor causing variation of their original series. So variance is a measure of dispersion of the set of the data point around their mean value. It is a mathematical expectation of the average square deviation from the mean. So variance is also indicated by small s square. So small s is nothing but the sample standard deviation, and when we square it, we get variance. So mean square is also known as somehow. So the arithmetic mean and the square deviation of the individual score from the mean. In other words, it can be said that the mean of the square deviation of the score is called variance. So variance is expressed by capital B is equal to standard deviation square of the standard deviation. So with this, I would like to summarize these sessions, what we have discussed in this session. In this session, we have covered four major things. One is called quartile deviation, second is called average deviation, third one is called standard deviation, and the last one is the variance. Although the standard deviation and variance are similar to each other, only the function is different from each other. So with this, we can understand how we can calculate the measures of variability. So in this session, we have covered almost all the measures of variability that you have to cover in your syllabus, in your courses. And I hope you have understand all the concept. I would suggest you to go and practice all the calculation, compute a standard deviation, compute quartile deviation and average deviation, and see whether you are competent enough to understand all these concepts or not. And I would also suggest you to go and see the different textbook for your more understanding and for your more understanding about the variability. Thank you so much for your patience. Have a nice day. Goodbye.